Hi students, in the previous class we discussed the working of a half-wave rectifier. Now we can discuss the working of a full-wave rectifier. So we already discussed the full-wave rectifier is classified to two types. One is center-tapped full-wave rectifier and the other one is a bridge rectifier. Okay, now we want to discuss the working of that is center-tapped full-wave rectifier. Center-tap full-wave rectifier. Okay. We want to discuss the working of this center tap full wave rectifier. So first we want to draw the diagram of that center tap full wave rectifier. So the major difference between this half wave rectifier and the center tap full wave rectifier is that the number of diodes in this center tap full wave rectifier is 2. Okay. So we want to draw the diagram of that center tap full wave rectifier. So here again it consists of a transformer. Then there is 2 diodes are there. This one diode and this second diode. Okay. Then this is connected to a load resistance. This is the diagram of that center tapped full wave rectifier. This is the primary of this is secondary, and this diode we are named as D1, this is D2, and this is load resistance R. Okay. Then this and this we are denoted as A, and this is B, and this is O. Okay. Then center tap means if the secondary voltage, maximum secondary voltage across this A and B is some value, and this in between one and then that center will be just half of that voltage. Okay. If the voltage 10 volt ആണെന്നുണ്ടെങ്കിൽ ഇതിന്റെ ഇടയിലുള്ള voltage 5 ആയിരിക്കും. അതാണ് center tap എന്ന് ഉദ്ദേശിക്കുന്നത്. So this is the diagram of that center tap full wave rectifier. Now we want to discuss what is the working of this center tapped full wave rectifiers. So again we want to consider 2 cycles. That if we consider the input voltage, it will be like this. Okay, so it consists of a positive and a negative half cycle. So first we have to discuss how it works when it is connected in during the positive half cycle. So during positive half cycle, then we can say this end A is positive and end B is negative. End A is positive and end B is negative. Okay, end A is positive and end B is negative. And what happened with respect to this O? End A is positive and end B is negative. So this diode is in forward bias. This diode is in forward bias and this diode is in reverse bias. So the D1 will conduct. D1 will conduct and D2 will not conduct. Okay, the D1 is in forward bias, so it will conduct a current, and the D2 is in reverse bias, so there is no current conduction due to D2. Now we want to check what is the direction of current flow. Current flow direction. So this is in this D1 is in forward bias, so the current flow is from P to N. So this direction will be like this. So we can mark the positive and negative of this resistance. The current entering in the direction of positive and denoted, this is negative. So the current flow will be like this. So we can draw the output is like this. It will be like this. This is input voltage and this is output current. Okay. Then during negative half cycle. That means the polarity is get reversed. This polarity become negative and this become positive. That is end A is negative and end B is positive. Okay, end A is negative and end B is positive. Then നേരത്തെ just opposite സംഭവിക്കും. അത് D1 എന്തായിട്ട് മാറും reverse bias നും D2 എന്താകും forward bias നും. Okay, so we can say D2 will conduct current and D1 will not conduct current. D2 will not conduct. Okay. D2 will conduct and D1 will not conduct a current. That is the situation when it is during the negative half cycle. Then again we can check the direction of current flow. Current flow direction. So this D2 is in forward bias. Again the current is from P to N. So it will be like this. Okay. So again the positive is this and the negative is this. That resistance is positive value, negative value. In both cases, the current flow is either diode D1 or D2, but the direction of current flow is same. Okay, during positive and negative half cycle, there will be current flow. In positive half cycle, current flow is due to D1, and negative half cycle, the current flow is D2. But the direction of current flow is same in both the half cycles. So we can draw the diagram like this. This is the diagram. So the AC voltage that is considered positive and negative half cycle that is converted to a signal in unidirection. The process of rectification is done using for the full cycle. Okay, the full cycle and the rectification we get a unidirection voltage current for a input voltage. So this is the working of that center tapped full wave rectifier. During positive half cycle D1 conduct, during negative half cycle D2 conduct, and we get output voltage for both the positive and negative half cycle in one direction. Okay. Now we can discuss an important term in that center tapped full wave rectifier, that is peak inverse voltage. Represented as PIV. In the first class, I just defined a term, breakdown voltage. When we connect a diode in reverse bias, after particular voltage, there will be anomalous increase in current. Then it will reach a maximum voltage. Then it cannot withstand that increase in current and will break down. That is a breakdown voltage. Then this term is also related to that breakdown voltage. Then we can define this peak inverse voltage as the maximum reverse voltage that can flow through a diode. This is the peak inverse voltage. That is, a particular diode reverse voltage peak inverse voltage. This is diode withstand breakdown. Okay, so this is the peak inverse voltage. Actually, this peak inverse voltage is always depend on the amount of doping of that diode. That manufacturing the doping it have a specific peak inverse voltage value. Okay, already set value. We want to discuss what is the relevance or significance of this peak inverse voltage in this circuit. This circuit is relevance. Circuit consider during positive half cycle, this D1 is forward bias. At that time, this D2 is in reverse bias. Okay, or in the negative half cycle, when D2 is in forward bias, the D1 is in reverse bias. Okay, so one particular forward bias is the reverse bias. When we circuit, reverse voltage maximum D2 across D1 across maximum reverse voltage. Okay, that voltage is corresponding diode choose. The peak inverse voltage for a particular diode is a constant. Now we want to find what is the maximum reverse voltage that can flow through diode in this circuit. In this center tap full wave rectifier. Now we have to choose that particular diode which having that much peak inverse voltage. So we want to find the value of that peak inverse voltage of each diode. So PIV of each diode. Okay, clear on the peak inverse voltage of each diode. So suppose if you are considering the positive half cycle, that means this is positive, negative, and this is positive. So that means this diode D1 is forward bias and D2 in reverse bias. Suppose if you are considering plus Vm, that is the voltage between these O and A, maximum voltage between these two terminal is Vm. Maximum voltage is plus Vm. That means this plus voltage will forward bias this circuit D1. Forward bias. Minus Vm will reverse bias this D2. And plus Vm will forward bias the circuit, that much voltage will reverse bias that this D2. Okay, that D2 will reverse by that much amount of D2. That much amount of voltage. Okay, so what happened that then this plus Vm due to this 4 plus 4 Vm voltage, the diode will conduct current flow through this load resistance. Okay, then that minus Vm will reverse bias this diode. Okay, then due to this forward bias of this D1, there will be a current flow through this load resistance. Okay, there will be a current flow through this load resistance, or voltage will drop across this load resistance. Then that voltage will also reverse bias this D2. Okay, the D2 already minus Vm or reverse voltage. In addition to this voltage, due to the forward biasing of this D1, then there will be a voltage drop across this load resistance R. This will also reverse bias this diode. Okay, so if you are considering that value as Vm, again that is value also is equal to minus Vm angle, total peak inverse voltage will be equal to 2Vm, or each diode D1 or D2 is equal to 2Vm. This is the case. When during D1 forward biased, the D2 is reverse biased. If the maximum voltage is Vm, minus Vm will reverse bias D2. Then in addition to this voltage, due to the forward bias of this D1, there will be a current flow through this load resistance. That voltage will also reverse bias this D2 due to that series connection. So the total reverse voltage or peak inverse voltage of this diode is 2Vm. This is D1 during the negative half cycle, this polarity gets reversed. So it is opposite. Again the reverse voltage, maximum reverse voltage of that D1 is 2Vm. ഇനി നിങ്ങൾക്ക് ഒരു സംശയം ഉണ്ടാവും, ഈ ലോഡ് റെസിസ്റ്റൻസിൽ കൂടെ Vm തന്നെ പോകുന്നത്. അത് നമ്മൾ ഐഡിയൽ മാക്സിമം എക്സ്ട്രീം കേസ് വെച്ചിട്ടാണ് നമ്മൾ നോക്കുന്നത്. അതുകൊണ്ടാണ് ഇതിനെ നമ്മൾ എന്തായിട്ട് എടുക്കുന്നത്, Vm ആയിട്ട് എടുക്കുന്നത്. സോ ദിസ് ഈസ് ദ പീക്ക് ഇൻവേഴ്സ് വോൾട്ടേജ് ഓഫ് ഈച്ച് ഡയോഡ് ഇൻ ദിസ് കേസ് ഈക്വൽ ടു 2Vm, or we want to choose a appropriate diode which having the peak inverse voltage equal to 2Vm. And if you know the value of maximum voltage across this transformer and center tap, then we can calculate the maximum reverse voltage that will flow through that D1 and D2. Then we choose a particular diode which having that particular value of peak inverse voltage. Okay, so this is the definition of peak inverse voltage and that of the value of peak inverse voltage for that center tapped full wave rectifier. Okay, now we want to discuss what are the demerits of this center tap full wave rectifier. Demerits. First demerit is it requires center tap. That means that's one demerit. The first demerit. Then second one is each diode gives output only for half of the input voltage. Okay, each diode gives output only for half of the input voltage. That is, if this is a transformer connection, and each case this diode conduct in either corresponding item, half portion corresponding item. So each diode gives output only for half of the input voltage. It will not utilize in the whole secondary voltage in a corresponding item DC conversion. This is the second disadvantage. The third one is peak inverse voltage of diode is high value. Peak inverse voltage is high. That means in this case the peak inverse voltage of each diode is equal to 2Vm. As the value of that peak inverse voltage increase the amount of doping വ്യത്യാസം വരും, അല്ലെങ്കിൽ അതിന്റെ റേറ്റിലും എക്സ്പെൻസിനും ഒക്കെ കൂടുതൽ റേറ്റ് വരും. അപ്പോൾ അതുകൊണ്ട് തന്നെ this is the third limitation of that and demerit of that center tap full wave rectifier. It requires center tap and each diode utilize only half of the input voltage and peak inverse voltage of that diode is high. So in order to rectify these limitations, we introduce that bridge rectifier. അപ്പോൾ ഇത്രയാണ് center tapped full wave rectifier working and the peak inverse voltage and what are the demerits of that center tap full wave rectifier. Okay, thank you.